For over 13 years, Bridge for Phidgets has been enabling FileMaker developers to sense and control the physical world through smart Phidgets devices directly from FileMaker Pro. Today, we're releasing version 4 of this plugin, where we have added support not only for 13 new VINT sensors, but also for FileMaker Server. That means you can now use our plugin to automate monitoring of your server's rack temperature, tracking access using RFID tags, unlocking doors, and anything else you can imagine. All that 24 hours a day without having to leave a dedicated FileMaker Pro client open all the time. Let me show you how easily you can use it to monitor your server temperature and automatically switch ventilation on and off as needed. I will use the temperature Phidget sensor to measure the temperature, and the Phidget SBC4 to access the sensor over network. I will take a note of the SBC serial number and connect the sensor to the port number 0. I also want to be able to turn a ventilator on to cool the server down when it gets too hot. So I will use a relay Phidget and connect it to the port number 5. I will use a small USB fan for this demo, but I can easily switch any other electrical device with the relay as well. Now I can just plug the power and Ethernet cable in, and I'm ready to set up the software side of the solution. Here I have a simple database I prepared for this purpose. It has a table to store temperature measurements and any generated alert messages. I also have a very simple 24-hour chart here. In order to use the database with Bridge for Phidgets on server, I have added a special user account and gave it the privilege to access the database via FileMaker Data API. Then I uploaded the database to my FileMaker server. On the server, I also installed Phidgets drivers, 2-for-You Phidget Manager, and the actual Bridge for Phidgets plugin. Note that the plugin needs to be installed in 2 different places on the server, one to make it available for the server-side scripting engine and another one for the FileMaker Data API. Then I added a few custom functions to hold all potentially configurable options in one place. Here, I can easily set what temperature should cause the ventilator to go on, how often I want the current temperature sample to be recorded, or where my sensor and relay are connected. The only piece remaining for the puzzle was adding a few scripts. I started with one to establish connection to the SBC. That is easily done with a single script step, providing the address and password of the SBC. It's always good to check whether any error prevented the connection. I decided to simply return it as a result of the script. My second script tells the SBC to switch the port number 5 to the digital output mode. This is necessary for being able to switch the relay to turn the ventilator on and off. The third script configures the Bridge for Phidgets to create data record in my database after every sample interval. I have set the interval to 300 seconds, so it should create a new record with the current temperature every 5 minutes. Here, I tell the plugin to put the sensor value to the field named temperature. The next script tells Bridge for Phidgets to run a script whenever the temperature changes by more than the defined step. It would be normally sufficient to set the step to 1 degree, but for this demo, I made it 1/10 of a degree so that the script triggers more often. This option specifies which script will fire, and this one defines what it will receive as a parameter. And this is the script that will run every time the temperature changes by at least 1/10 of a degree. It starts by extracting the temperature from the parameter, making sure it's correctly converted to a number, including the correct decimal separator. Then it checks if the temperature exceeds the value set to turn on the ventilator, and if the ventilator is not on yet, it will try to activate it and generate an alert. Likewise, when the temperature falls under the value set to turn the ventilator off again, the script will take care of it and generate another alert. Turning the ventilator on or off is done simply by writing 1 or 0 to the correct digital output. In addition to recording the temperatures and alert message in the database, I also made the script send a push notification to my mobile phone so that I know when my server gets so hot that it needs the ventilator to cool it down. To activate the whole thing, I have to run all the setup scripts on the server. This needs to be done only once because Bridge for Phidgets remembers the settings even after restart. To secure the database against hackers, I reset the Data API password to a new randomly generated one. Then, I perform the individual scripts on server and display the results in a dialog. So let's try it all out. That's it! Now my server started recording the temperature every 5 minutes and also triggering my automation script whenever the temperature changes by more than 1/10 of a degree. Can you see how new records are appearing? As soon as the temperature exceeds 26 degrees, the ventilator will turn on and start cooling the thing down. Once the temperature drops under 25 degrees, again, the ventilator will go off. How do you like it? Are you ready to try it yourself? Then feel free to grab a copy of this sample database by clicking the link below this video and make sure to let us know what you think about it and how you're going to use it.